Hi, in this video we're going to be looking at direct and inverse proportion. We can see in these diagrams here proportions are an important part of what we look at in mathematics and study, the golden proportion, the golden ratio, those kinds of things. So these problems are going to be pretty simple, just describing what direct proportion is and then what inverse proportion is, particularly as inverse proportion relates to hyperbolas. So direct proportion is basically where one variable increases, the other variable increases. So if you have a graph like y equals 3x, a straight line, y is directly proportional to x. So it's pretty simple to solve problems like this. If y is directly proportional to x, then we can say y is equal to k times x for some value of k. That's it. So then if I give you some values, you can find out what the value of k is. In this case, it's the gradient. So when x equals 4, y equals 10, we can do this. And so that implies that k is equal to 10 over 4, or you could say 2.5. And then, a lot of questions then say, well, work out the value of y when x equals 6. So the value of y when x equals 6, now we know the relationship y equals 2.5x, we can say y is equal to 2.5 times 6. And then we can work that out with our trusty calculator. How would we do this without the calculator? Well, the answer is 15. So I guess I'm going to go 2 times 6 is 12, half times 6 is 3, and add those together. So y equals 15. That's a basic example of direct proportion. If you have a look at these graphs, which one of those is direct proportion? Only the one in the middle. All right, this one here, because it's starting up on the y-axis there, that is not direct proportion. And this one here is going down and again starting at this value here, so this is not direct proportion. So only straight lines coming straight off 0, 0 are direct proportion. Let's take a look at inverse proportion now. So in inverse proportion, as x increases, y decreases. So we say y is inversely proportional to x, and we write it as like this: y is proportional to 1 over x. That's what that symbol there in the middle there means, proportional to. So as an equation, we write it as y equals k over x, like this. So similar to the last question, let's look at this example here. If two quantities x and y are such that y is inversely proportional to x, in other words, y is equal to k over x. When x is 20, y is 6. That's going to help us define what the value of k is, and then we can work out the values of the other variables. So I've gone ahead and done this. So when x is equal to 20, y is equal to 6. So solving that equation, timesing both sides by 20, we get what k is equal to 120. So the actual equation is y equals 120 over x. And now it's easy to work out the others. When x is equal to 40, y is equal to 3. When y is equal to 2, times both sides by x divided by 2, x is equal to 60. If we have a look at the graph, which one of those three graphs there show us inverse proportion? Well, it's certainly not this one. Even though as one is increasing, the other is decreasing, it certainly doesn't fit the bill of y equals 1 over x. And we know what the graph of that looks like. That is this one here. So this is the one here showing inverse proportion, not this one here either. So that third graph there shows us what inverse proportion would look like.